why does a 30-degree phase shift occur in a star delta transformer? Okay, so if you take a star delta transformer, the primary side will have RYB, okay, and the secondary side we will label them as R dash, Y dash and B dash, just to differentiate. Okay, so this is the three-phase transformer which is in the star delta configuration. That is, the primary is in star and the secondary is in delta form. Okay, so now what happens is the line voltages on primary side, which is in star configuration, is going to lead by 30 degrees the line voltages on the secondary side, which is in delta configuration. So mathematically, if you see the voltage between these two lines, VRY is the line voltage, on the secondary side VR dash Y dash. So VRY is going to be, the phase of VRY is going to be the phase of VR dash Y dash plus 30 degrees. Okay, similarly VYB and VY dash B dash is also going to lead by 30 degrees. VBR is going to lead VB dash R dash by 30 degrees. Okay, so this is all with respect to the phase. So why is this happening? So we can understand this when we look at the windings. Consider a single phase transformer. Okay, so this is the single phase transformer. This is the primary side and this is the secondary side. Now both of these transformer, both of the voltages, that means the voltage across the primary and the voltage across secondary, they will be in phase, right? Primary and secondary voltages will be in phase. That is what happens in a transformer action. There will be no change in phase. So this is single phase transformer. Now what is happening in a three-phase transformer? So on the primary we have the star configuration, right? So first we will draw the star configuration. So this we will take as R, this is Y and this is B, and this you can take as neutral. Okay. Now how is the delta side going to look like? So we will draw it in this way. So why I am drawing it this way, I will explain in just a second. So this winding here, Rn, this is going to induce the voltage in this winding. So I have represented both of them parallelly. Okay. Now Yn winding, this is going to induce the voltage in this winding. Okay. Similarly, Bn is going to induce the voltage in this winding. So I have drawn all of them parallelly, just for making clear which winding is corresponding to which winding. Okay. So now we will label. This winding is going to induce in this winding, right? So R and N should be reflected here. So that means if positive is here, at the same time there is going to be positive here. Okay. So since there is no neutral on the delta side, we will just write R. So we will write R dash to differentiate between primary and secondary. Okay. Now next, this winding Yn is this, right? So since at this point Y is there, at the same point Y dash is going to be there. So this is Y dash. Finally, B dash is going to be here. For this winding, on this side you have B. So for this, on this side you have B. Okay. So now we can draw the lines. This is going to be R dash. This is going to be Y dash. And this is going to be B dash. Okay. So now we will draw the phasor diagram. The neutral voltages, the phase to neutral voltages are VRN VYN and VBN, right? So you are going to have, this is Y. RYB sequence, so you are going to have VRN here, VYN and VBN. These are the phase voltages on the secondary side. Okay. So now the corresponding winding, there is not going to be any phase shift. That means whatever is the phase of VRN, the same will be the phase of the winding VR dash Y dash. Similarly, VYN phase will be VY dash B dash phase. VBN phase is going to be same as VB dash R dash phase. Okay. So the delta side voltages, which is the line voltage or the phase voltage, both are same for delta winding, right? So that phasor diagram is going to be like this, same as this phasor diagram. Okay. VR dash Y dash, VY dash B dash and VB dash R dash. Okay. So this is the line voltage phasor diagram on the secondary side. Now this is only the phase voltage, not the line voltage. Whenever we have a transformer or any power system equipment, what we need is the line voltage. Whenever any rating of an equipment is given, it is the line voltage. Okay. So now we have to get the line voltages, what will be the phasor diagram for the star side. Okay. So that how are you going to get? So VRY is nothing but VRN minus VYN, right? So how can we write this? We can write this as the phasor addition of VRN plus the phasor minus VYN. Okay. So that means we have VRN here, VYN here. What will be minus VYN? It is going to be exactly 180 degrees opposite to this. So you have minus VYN like this. So now if you add these two phasors, you are going to get VRY. So the phasor addition is going to look like this. Now we know this angle is 180 degrees because this is a straight line. And what about this angle? This is going to be 120 degrees. So what will be this angle? It is going to be 180 minus 120, right? So you're going to be left out with 60 degrees. Now since this is a balanced system, VRN and VYN will have the same magnitude. When there is a same magnitude and you are adding these two phasors, what will be the resultant phasor? It will be the angular bisector. So this angle is going to be 30 degrees. Okay. So now what will be the line voltage phasor diagram on the star side? If this is 0 degrees, okay, you are going to have VRY here, which is having a 30 degree phase, and then you have VYB here, which is going to be 120 degrees lagging VRY. So if this is 30, this is going to be 90, right? And finally we have VBR. What was the line voltage phasor diagram on delta side? This is what it was. VB dash R dash. Okay. So you can see that it is each of the line voltage. This is VR dash Y dash and this is lagging this VRY by 30 degrees. Similarly for VBR and VB dash R dash. Okay. So that is how the star side leads delta side by 30 degrees. If the primary is star side, then primary will lead by 30 degrees. But in case it is a delta star transformer, that means if the primary side is delta, then the primary side is going to lag by 30 degrees. Okay. So this is with respect to the line voltages. So instead of simply remembering as star side leads delta side by 30 degrees, it's best if you remember star side line voltages lead the delta side line voltages by 30 degrees.